Good morning! So today is Fancy Friday and now we are going to talk about caching. I know, right? So exciting, caching. Right, let's define some things first and foremost, because the thing is with caching is that the concept exists in many different areas and there's a lot of different ways of doing caching. So I will just kind of define the way that I think about caching and what it actually means. So caching is, in my opinion, the idea that you have something that needs to go somewhere, and what you want to do is to identify some type of information, something that can be a little bit stale, data that doesn't have to be crisp fresh every single time you get it, so that you can put it closer to the thing, or like the client that is going to go after it. That sounds really fancy, but it's actually a very simple concept. Think of it in the terms in the browser, for example. You may or may not know this depending on your level of experience with computers, but when you visit a web page, what usually happens is that you pull down a bunch of files, CSS files, JavaScript files, etc., and for the very first time. So you may have noticed that the first time you ever visit a web page, it takes a little bit longer, and that is because you're getting all these files. The second time, if you reload the page, it's going to be much faster. The reason is because your browser is going to cache the files that are a little bit static, or files that aren't changed all that much, such as CSS files, JavaScript files, and so forth. See, the power of this is that now we can only send the stuff that is most likely going to change quite often, which is usually the text, the HTML, so forth, that's on the page. So that's one type of caching. And then you have memory caching. Let's say that you have let's say that you have a system that needs to do a lot of computations, and you need to, in memory, store the results, or rather you need to store the results of your computations, and you need to, in a very quick manner, access that information. Then you would have something called an in-memory cache, and an in-memory cache is basically, it's a very simple thing. It's really only when, or I'll just define some things to kind of make this make sense. So when you're running your program, what's happening is that, all the variables, all the things that you run are allocated in the computer's memory. And that's in essence how it stores the values in order to do its computations. And what programmers in general will talk about when they talk about an in-memory cache or something like that is that they will actually use that memory to store data so that you can use it in a very quick manner, because the time it takes, let's say that you create a bunch of computations, a bunch of results, and then you write that to a file on the disk or a database of some sort, that is for the most part going to solve your problem if the computation is very slow. Let's say it's a user visiting your website or so forth, then it makes sense to write that to a database or a file. But if you are running a really heavy computation where it's just, it's all happening in one algorithm, it's very ineffective to write to disk because it takes a lot of time. The distance for your program to go to the file system, read things from file and then into memory, and then do its computation and write back, is much longer than just going into the memory. So that's a good rule of thumb for you to remember. The fastest place to store any type of information is in memory. Now that has its drawbacks, of course, because memory is a little bit, that's another topic, but rule of thumb is in memory is the best place to store things. But you should also remember you can't just store a lot of stuff. We actually have, at work, the more you store in memory, the more memory you need to allocate. So it's a trade-off. It's effective for speed, not so effective for cost. So that's the second type of memory. or caching solution. And then finally you can have a dedicated caching database, or rather, and it's not a caching database per se, but it builds on the same idea. And my choice of caching solutions for things that need to be not, because in the first memory cache, if you store it just in a variable or in a hash map in your system, what's going to happen is that when you shut your computer down, the cache is going to go away because the computer is going to let go of all that memory, and you lose all that data. So that's that solution is very useful for things that doesn't have to stick around for a long time. But if you need something a little bit more permanent, let's say that you do session handling. And session handling, is a perfect candidate for using something like Redis. Now, what's Redis? Well, Redis is a database Redis is a database, basically. It's a very, very effective database for storing things in memory. The difference between using Redis, there's a lot of stuff that you can do with Redis, but let's just call it the main difference is that if you shut down your computer, Redis will keep everything in memory while your system is running, while Redis is up and running, but it will also store things to the file system. So you can actually shut down the system, bring it back up, and Redis is still gonna remember the data that you stored in it. So Redis is a very popular database for doing, it's not using as the only database, but doing caching, storing things that you need to get to the client quickly, or you need to have access to in a very quick manner, which is usually, like the most common one is to use it for session handling. And if you don't know what session handling is, just put a comment or something like that, and I'll make a video about what sessions and session management is. So these are the three things in general that caching is about. And when you're working at scale and you're doing like when you have a fairly large computer system, it's fairly important to know about caching. And it's for the same reason, like I've made a few other videos about this, and they kind of all, I hope that if you watch them, you will see that I'm trying to kind of nudge you without saying it to, I'm not going to be too on the nose and tell you exactly why, but you may have noticed that everything at scale works towards one thing, and that is performance. Because at scale, the main problem that you have to deal with is performance and resource management and stuff, resource management and so forth. That's usually the case. And it's actually funny because you may think that the code is the part that changes when you have millions and millions of users. And in some way, in some very specific places, it may change because you have that type of scale, but it's very rarely the case. Most of the time it has to do with just figuring out how to basically run the application, because when you have a lot of users, a lot of data, you have to be more conscious about the physical limitations of, well, reality, if you will. It's that simple. So that's where caching is one strategy to deal with that. So the mindset that you should have for caching is, if you're doing web, it's fairly standard today to cache all like CSS files, JavaScript files, that sort of stuff. That's fairly straightforward. And then you will use a hash or something in the file name, which changes whenever you change the file, so that your user gets the updates and so forth. I actually made a few videos about this as well. You can check those out. It's called like Webpack something, hashing, something like that. Anywho, so what I want you to take away from this video of mine is that when you're thinking about caching, you need to be careful, because caching is very difficult. You don't just want to cache anything, because you need to really think about what data is okay to not have crisp fresh every time the user needs them, or your system needs it. Because if you're caching everything, remember, you need to figure out how to notify the cache to, hey, there's new information now, can you please update this and send, and when somebody wants to access it, just give that new updated version. And that's actually one of the trickiest part about caching, to figure out when you need to stop going to the cache and start going to the source of that information. And to give you a small hint of how important caching is, progressive web applications that you may have heard of is actually the main reason why they are coming around and why they're being popularized, is because that's exactly what they do. They allow you to control exactly what the browser is going to go to the network to get. And that's very, very powerful. That's why just think about that. Progressive web applications is designed, or rather its intended purpose is to allow really, really powerful caching strategies. That's how important caching is. So if you want to be a real whiz kid with performance and working at scale, take a good hard think about caching and learn even more about it, because it's a very powerful concept to be good at.